Hey everyone, my name is Justin Weinberg, and on behalf of the team at 101, I'd like to thank you for using Chem 101, and I hope it's able to help you out with your chemistry course this fall. In this video, I'd like to teach you how you can use the app to intuitively draw any Lewis structure on your mobile device. To do this, I'm going to go over two example problems from the app, and the first example I'm going to go over is a question on drawing the structure of formaldehyde, or H2CO. Now, while I'm doing this, I'm going to put the correct structure of formaldehyde on the left so you can see what our goal is in terms of drawing the structure. Now, in terms of actually drawing the structure in the app, all we need to do is just tap on this plus button, which brings up our drawing tool. And by default, we start with a diatomic molecule with two placeholder elements as solid circles. And it becomes our job to build from the structure and draw the final structure of formaldehyde that we want to obtain. So you can see that this left placeholder is in red, which means that it's selected and active. But actually, every element in the structure or bond is selected by just tapping on it just like this. So you can see that no matter what I tap on, it turns red, which means that it's selected and it's active and I can change its properties. So if I want to add some more bonds to this left element, I can select it and drag my finger along this right-hand dial to change it to 3 bonds, for example. Now let's say I want to change that central element to carbon. Since it's selected, I can just tap on the periodic table button on the bottom, which of course brings up the periodic table and allows me to select any element that I want. So I can pick carbon here, and then I can fill in the remaining elements, which are hydrogen and oxygen, by just selecting those elements and using a convenient shortcut, which is just double tapping on that element to bring up the periodic table. So I'm going to put hydrogens on the bottom and an oxygen on the top. And that completes our skeletal structure. Now to help me out, I can use a convenient tool here, which allows me to track the number of valence electrons per element so I can make sure each of my carbon and oxygen elements are obeying the octet rule in this case, since they need 8 electrons. So to put a double bond between the carbon and the oxygen, all I need to do is just tap on that bond and drag the dial on the left-hand side to make it a double bond. And to finish up the structure, I can drag my finger along this lone electrons dial on the left-hand side as well to put in 4 lone electrons or 2 lone pairs to complete out the structure. To save my work, I hit save on the bottom right. That gives me a convenient picture of what I've drawn, and then I can submit my answer on the top right. I confirm my submission, and then the app tells me that I've gotten the correct answer. And in the case that I didn't get the correct answer, the app would give me specific feedback on my structure so I can learn from that and correct my understanding. The second example I'd like to go over is a little bit more complex, and in this question we're asked to determine the number of valence electrons in ethanol, C2H5OH, and then to draw the corresponding Lewis structure. So if we look at our molecular formula, we would add up the valence contributions from carbon, hydrogen, and oxygen, and then we would of course select 20 valence electrons D for our answer. And then when we go in to draw a structure, we just need to tap on our plus button to bring up our tool. And what I'd like to demonstrate with ethanol is our ability to handle structures with multiple central elements. So I can start by drawing the structure by putting 4 bonds on our first element, tapping on one of our outer elements, and then expanding that to 4 bonds, and then expanding the structure once more to account for our oxygen OH bond. We can then put in our elements by double tapping on each of these placeholders and bringing up the periodic table, putting in all of our hydrogens first. Put in our oxygen, and finally carbon. And to finish up the structure, we would add 4 lone electrons on our oxygen, save our work, submit, and of course get confirmation that this is the correct answer. So that's it for this brief tutorial. I'd like to thank you for watching, and if you have any questions, please feel free to email us at support@101edu.co, and we'll get back to you as soon as possible.